the digital electronics for a couple of years, but I think this is the best example I have ever seen. So last year, when I was waiting for my 3-year-old daughter outside of the preschool, and there are 2 doors, actually, Needham Elementary, right? So the entrance, there are 2 doors. One is 20, another one is 22. Let me write it down for you. So one read 20, so on the top of the door, so that's probably the number of the room, and the other one is a 22. And there was a about 3-year-old young boy and his mom, apparently. So his mom told him, this is 20. That's how you pronounce it, right? And then she didn't tell his son, what is this number? And you know what he said? He said 2020. This is correct, right? This is 20. So this should be 2020. They are both tools. Why is not 2020? Why it is 22? After I heard this, I just told her mom, he's genius. Because this is absolutely correct. I read a 22 like this, and you know it's not 2020, it's 22, right? If I had it, is this 2 or 20? You don't know. You couldn't say it's 2 because I am hiding here, right? You don't know what's behind it. So you actually don't know. If I do this, do you know what it is? I think that's right. There's nothing behind it, right? So anybody has any ideas about why he made that mistake? The 3-year-old boy. Why it's not 2020? Any ideas? Any? I just want to you guys get engaged, just not just passively receiving information. Think about it and why you couldn't pick up the mistake. What's that? Yeah, so the issue is actually this guy. Or you can say this guy, because whenever he saw this 20, so 2 probably should be pronounced as 20, but he saw 2 here. They are not both 20 because you just place this 2 at here is going to be 20, but this 2 at here it won't be 20 anymore, just because of the location. The God didn't tell us to make a 22 like this. We made it. Do you agree with that? Okay. This is 2. That's from the nature. Absolutely, this is 2. But we're telling our kids in elementary school, this is 22 because we made it. The God didn't make it. So here's the question. Why these 2 represent 20, but not 2000? Yeah, also because of the location, right? It's just 1 digit in front of this number 2. So that's why it's 20. It is 20, not 200, not 2000. But we didn't label that. We didn't label here, hey, this is 20. This is 2 times what? 10. We didn't write it, but however, this just represents 20 by default. Okay? Is this interesting? Anything related to computer? Not yet, but it's soon, right? Something is coming. why do we carry out after 9? Have you thought about this question? Why after 9 we are going to repeat, we are going to reuse the other Arabic numbers like 1, zeros? Is there any character representing 10? No, it has to be 2 digits, right? There's no single symbol to represent that. But why? I mean, did the God tell us to do this, or we just invented? This is a 10-based number system we're so used to, right? If you talk about $1,000, it is $1,000. It is 10 times 100 or 100 times 10. Why 10 is everywhere? Who tell us to use 10? Why? Because everything is calculated within this 10-based number system. And nobody tell us we invented. But why 10? Why not 9? Like 1, 2, 3 until 8, then 10, just keep 9, no 9. I think, probably a million years ago, since we have 10 fingers, that's probably why. Yeah. However, a computer or any digital system you have, like a tablet or desktop, smartphone, any digital system, they actually don't understand decimal numbers. It's a binary system everywhere in the digital systems. They can display a decimal number because they have a monitor, they can form it. But however, all the numbers being stored inside the computer is a binary number, only 1 zeros. That's a binary number. So that's another different number system compared to the 10-based number system. It is a 2-based number system. So which means in that number system, there's no number 3. 0, 1, what's next? 3? No, you couldn't pronounce that one as 3. It's not 3. 10? No. 10 only show up in the 10-based number system. In binary number systems, there's no 10. There's no 3. You have to pronounce it in a different format. Let's look at it. Another paper. That's very interesting. That's why I'm thinking everybody should know this. That's critical. It's everywhere, and you don't understand what's this, and you're an engineer. Shouldn't say you're an engineer if you don't know digital system. All right, the binary. So for the decimal or 10-based decimal numbers, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17. If we're using a binary number system, what are these numbers in binary form? 0 in binary is 1. Really? I have 0, but I convert into a binary number system, I got $1. Yeah, let's use binary system. $0 become $1. 0 in decimal will be what in binary? 0. All right. 1 in binary. Not 2. 2 in binary. Why 1 0 or why not? So look at here. After I'm out of numbers, I have to reuse the other numbers. I have to have a carry and reset that bit or that digit, right? So you have to carry out and then reset it since you are out of numbers, right? So 10 here, you pronounce this as 10. For a binary number, for 2, since you don't have 2 in binary number system, so it has to be what? Carry reset. How to pronounce it? 10. Is that 10? How to pronounce it? 2. No. How to pronounce it? 1 0. What about 3? So 1 0 plus 1 is what? 11. How to pronounce it? 1 1. What about 4? 1 1 plus 1. So 1 plus 1 is carry and 0. 1 plus 1 is carry and 0. So what is 4? 1 0 0. What about 5? 1 0 1. 6. 1 1. 1 0 1 plus 1. What is that? Carry 0 1. Right? And no carry 1. 1 1 0 is 6. What about 7? Is that 1 1 1? Over there? Is that 1 1 1? Good. 8. That's 16. Oh, serials. Yeah, that's 8. Carry 0, carry 0. So that's number 8. 9, 10, 11, 12, 13, 14, 15, 16, 17. Did you get that? There? You? Both of you? Great. That's binary. Okay. And there's another number system that's being used in the computer system very often. It's called hex. Stands for hexadecimal. Is that A or I? Should be A, I think. Hexadecimal. So it's a 16-based number system. All right, 16-based number system. What is 0 in here? Do we have 6 in the 16-based number system? Do you have 6? So the decimal number is a 10-based number system, right? So you can have all the numbers up to 9. You have to carry after 9. For the 16-based, you are expecting somewhere after 15, you have to carry. So we definitely can use all the number up to 9. So you are thinking like, what about 10? What about 10 in hex? We gotta be creative. Alpha, beta, 10 in Chinese. That's 10 in Chinese. Plus sign. So what's the standard 10 in hex? 8, yeah. 11, it's not B, it is B. 12, 13, 14, 15, 16. What's that? Same rules. Carry out and reset. 0, 0. 1, 0. Yeah. So in hex, this is 16. All right. It's not 10, not 2, not 1, 0. It is 1, 0. It is 1, 0 actually. Or you can say 16. Okay. It's 16 or 1, 0. 17. 1, 1. Shouldn't say 11. Right. 1, 1. Okay. These are the most important number system in the computer, any computers. Okay. And let me give you another example, see if you have learned this. It doesn't exist. However, just want to let you know. Okay, I'm gonna scan this and upload to my website. No worries. So don't worry about the notes. Okay, everything will be online later. Let's have some fun. There's another system called Octal. This is how much based, you think? 8 based. Let's do it. So that's 8 in octal number system, 8 based number system. This is 9. What about 10? Until what? Yep. What's next? Octal. What's next? After 17, what's next? What is 17? I know you know it, but what about others? What is 17 over there? What is 17 in octal? What is 17? Any answers? What is 17 in octal? 15 is 8 plus 7, right? So what is 16 in octal? Huh? No, how to write it down? How to write it in octal to represent 16? Think about it. So after 7, and you don't have 8, you have to carry out and reset. So what is 16 in octal? Come on, what's 16? Why? Oh, 20 or 120? Why 1? Why 1 is here? 20 is correct. That's 16. Why? Because 1 represents 8, so 2 is going to be 16. And also, you can think about the other way, because there's no 8, right? So 17 plus 1, it's going to be 8. So I have to carry and reset, and this becomes 2. Is that correct? So every digit can go up to 7 in an 8-base number system before carry out. Any questions by far? No? Okay. So let's do the conversions. Yeah, this is too complicated. Let's do this first. Convert a binary number to a decimal number. How to do that? 1101, that's a binary number. How to convert it into a decimal number? Get an easier one. 10. What's the decimal number of 10? Let's come back really quickly. Let's look at the decimal numbers. Okay. 35. It's a 10-based number. It's a decimal number. 35. Exactly 35. The reason this guy is 35 is because it is, so 3 here represents 3 times 10, or you can say 3 times 10 to the first, plus 5 times 10 to the 0, which is 1, equals to 30 plus 5, which is 35. 255 equals to 2 times 10 to the what? Plus 5 times what? All right. Here's the answer for the kid. Why it's not 2020? Come on, if you have a kid, like in 5 years, for example, 10 years, they have the same question. How do you want to answer them? It's not 2020, it's 22. Why? I'm an engineer, but I didn't learn it. Why? It's hard to explain to a 3-year-old about the number systems, right? Whatever you're thinking about, you are explaining this to someone else who have attended school in the past. This is not 2020 because this tool is 2 times 10 to the first, and this tool is 2 times 10 to the 0. That's why. Very simple, right? And plus, so it's going to be 20 plus 2, which is 22. We place this 2 over here doesn't mean this is 2. Because this guy is at this location, so it's 20. It's not 2. That's it. So 255. We don't even need to think about it. We know it's 255 in decimal, 10-based number system. We have seen this a lot. All these different 100, 1,000, all these a few thousand, all these numbers. They are in the 10-based number system. We can read it instantly without thinking about it, right? Since we have been used to it. Now, it's a new number system. You are not used to it. So what is it? For 10 in binary, so they are in the 2-based number systems. So for 10, 1 represents what? It's 1 times what? So in the 10-based number system, it's 2 times 10 to the something. 10 is always 10, right? That's 10-based number system. In a 2-based number system, it's 1 times what? 2. What's the power here? Plus 0, because this is 0. 0 times what? So the power at this location, that's the second digit. You have to use that location minus 1 to get the power. right? So that's how you do it. So this equals to what? This is 2, this is 0. So what's the result for 1, 0? 2. That's how you convert a binary number to a decimal number. What about this guy? This one is what? 1 times 2 to the third. What about this? 1 times 2 to the second. 0 times 2 to the first. What's the result? What is this? 8. What is this? 4. What is this? 0. What's this? 1. What's the result? 13. Okay, so 1101 is 13 in decimal. All right. If you have been used to the binary numbers, you can do the calculation really quickly, because whenever you see something here and has 3 digits following this digit, that means if you have a 1 here, you got 8. If you got a 1 here, you got 4. I got nothing here, so ignore it. You got a 1 here, that's 1. All right, so what is this? So they are all multiples of 2, right? All these numbers. 8, 4, 1. So if I have a 1 here, what is this number? What's this number? 16, right? What's this number? 32. What is this number? 64. So now let's do a quick test, okay? 1, 0, 1, 1, 1. What is this? So I'll let you know how I calculate it, okay? I see 4 digits. I know this is 16. And I know this is 7 because this is 8 minus 1. All right, so it's going to be 16 plus 7. What is that? All right. You don't have to, if you don't know this is 7, which is fine. So which is this digit represent? 4, right? What is this? 2. What is this? 1. 4 plus 2 plus 1, is that 7? Yes, it is. This is 16, so 16 plus 7 is 23. So this is how you convert a binary number into a decimal number. So what about if it's not an integer? Then how do you handle that? It's not an integer. Like this. What's a decimal format? So we know this is 10.1, right, in decimal, right? You know this. So that's 10 exactly. And this is 0.1 because it is 1 times 10 to the minus 1. If you have another one, it's going to be 1 times 10 to the minus 2. I have a 2, it's going to be 2 times 10 to the minus 3. So this number is actually this. We just never say it. Okay, this is actually this. It's never tell everybody all the time. This is just a simplified version of this one. That's how that works. Okay. What about binary? What? What's next? 1 times what? That's why. It's a binary number system. You never have 10. That making sense? Making any sense? I think I know you graduate from high school, right? But however, I don't think they will teach you this. When you are learning a 10-based number system, you never thought about why we use 10-based number system and what does this point mean, really. You never care about it. They never teach you this. But by learning this digital system, the world is so clear right now. I know what the numbers mean, right? We just need 1 or 2 lectures to understand that. Now, one more thing. 101 is 101 in decimal, 10-based, right? If I divide this guy by 10, what's going to happen? What this equals to? So what's the mechanism of division? In 10-based number system, if I divide a number by 10, what I'm doing? I'm moving the decimal points to the left. It used to be here, but now it's this. And I divide this guy by 10 again, what's going to happen? Right? That's how this is designed. That's a purpose. Also, times 10. I'm moving the digit to the right. Okay? So, in binary, what is this? What is this? What this actually is in real world, in decimal example. So can I say this? Can I do this? Is this correct in binary? Look at this. 1 in decimal number 10-based, okay? Divided by 10, what's the result? 1 divided by 10, what's the result? 1 divided by 10, what's the result? 0.1. In 10-based number system. In binary, 1 divided by 2, what's the result? 0.1. Why? Don't calculate it. Just move the digit, please. Just move the digit. 1 divided by 2, move it. Is that 0.1? 1 times 2. What's the, no, oh, no, sorry. So 1 times 1, 0, right? In binary, what's the result? So 1 binary number, right? Times 2. Because 1 in 10-based times 10 is 1, 0. So that's why 1 in 2-based times 2 is 1, 0. Just move the digit. Do not calculate it. Is that clear? So that's why 1 divided by 2 in binary is going to be 0.1. Because I just moved the digit to the left. Any questions by far? So, what is this number? 1 times 2 to the minus 1. Any questions so far? It's clear now, right? Because this is just a 1 divided by 2. Is that a half? It is a half. Oh, yeah, yeah. So this is still 0. What is this? 1 times what? 2 to the what? So let me know. In binary, what is this number in binary? Convert to decimal. What is this? I know this is a half. And this is 0. This is, what is this? So what's the final result? This is in 10-based number system. Okay. Any questions so far? No? Now, decimal to binary. Conversion. How to convert a binary number to, a decimal number to binary. Let's do 25. How to convert it? Let me show you how I do it, and I will explain to you why. Divide by 2, I'm getting 12, and remainder is 1. Divided by 2 again, I'm getting 6, remainder is 0. Divided by 2 again, I'm getting 3, remainder 0. Divided by 2 again, I'm getting 1, remainder is 1. Divided by 2 again, the result is 0, and remainder is 1. And then what? Look backward. And that's exactly the binary number of 25. And why? Let's verify it. So if I look backward, it's going to be 11001, right? 2-based. What is this number? Is that 16? You have 4 digits. What is this number? 8. 0, 0, nothing, and 1. 25. Oh, so magic. Why? How to get it? How do you understand it? Why I divide the numbers by 2 in a row, and then I'm getting, if I combine all the remainders together, I'm getting a binary number of this number. Think about it. If I'm using 25 divided by 2, so the 25 is in a 10-based number system, right? I use this 25 divided by 2. What's the difference? I know I didn't know this at the very beginning, right? However, let me know any difference if I'm doing this. Since this is 25, it's also 25. Divided by 2, I do the same job. What's the difference? Or any difference? So you use the $25 in decimal, in 10-based number system. You divide the $25 by 2 for multiple times, and you are getting something, and a remainder, right? If you use a binary form 25, do the same job, you get a result, a remainder. Are we getting the same result and same remainder for the two 25s? Of course, it's just $25. Same number, but different format. Okay? So let's do this. Binary format. This number divided by 2, what you want to do for this number? What you should do? I just mentioned that in the last page. So a 10-based number, you divide that number by 10, you move the digit to the left. You times 10, you move the digit to the right. Is that correct? In a binary number system, you divide by 2, you move the digit to the left. You times 2, the number, you move the digit to the right. So now I'm dividing this number by 2. What I'm doing? Move the digit to the left. So the result will be 1100, and the remainder is 1. Is that correct? I do it again. I move the digit to the left again. I'm getting 110 and remainder 0. This guy is 0. Right? I do this again. I'm getting 1 and the remainder is 0. Do again. Result is 1, remainder is 1. And do this again. Result is 0, remainder is 1. Is that the same number? 11001, 11001. Are these the same numbers? Yes, they are. And did you get it? Why is this? How this works? Any ideas? Any thoughts? Because when you are converting a decimal number to a binary number, you didn't know the binary numbers. So the way to expose every single digit of that number is to divide it by 2. So you are taking out every digit as a remainder. Right? Just do it one by one. So you are going to take out every single digit as a remainders, and then you look backward. So that's the entire number here. Any questions? No? Did you get it? What about this one in decimal? How do you convert this one in a binary number? So see here, when we are converting this number into a binary number, we divide this number by 2 in a row, right? So we can expose every single digit in that number. But here, the way to do that is you times 2 to this guy, or you can say you divide this number by a half. So what is the result? 0.5. And what you want to do here right now is to take this, whatever the number is here right now, and take it out and put it here and reset this number to 0. If it's already a 0, then never mind, right? So then do this again. Divide this number by a half. What's the result? 1.0. So like what I mentioned just now, you take this number out and reset it to 0. Since you're getting 0, 0, you're done. No need to do anything further. It's going to be 0 always in the future, right? And what's next? From top to bottom, that's a binary number. Another magical thing, right? Why here's bottom to top? Why here's top to bottom? So this number in binary, if you look from top to bottom, this equals to 0.01 in binary. And let's verify it. So this is 0 times 2 to the minus first. Okay. This is 1 times 2 to the minus second. And that is 0.25. Exactly. That's correct. But why? Why this works? Why you are dividing this number by a half and you are looking from top to bottom this time, not like this. So still think about the decimal number, okay? 0.12 like this, decimal. If you divide this number by 1/10 or times 10, what's going to happen? you times 10 to this number. Let's do this. What's the result? So you are moving the digit to the right. Times 10 again. So move the digit to the right again. So every time, so for example, I times 10 for the first time, and I get something like this, and I'm going to take out this number, right, and then reset it to 0. Okay, so I have 0.2 left. And times 10 again, I got 2. And I take out this number, and you look from top to bottom. What is this? 1, 2. Is that 1, 2? Yes, it is. 0.12. You get it. In a binary, it's the same concept. You have this number. I know it's not binary form, but it's equals to this. We just didn't know that, right? However, we can use this method to take out every binary number out of it, right? So this number times 2 for the first time, it's a 0, so take 0 out. And the second time, you got a 1, take 1 out, and from top to bottom, it's going to be 0, 1. So 0.01 will be 0.25 in decimal. That's how to convert a decimal number to a binary number. Any questions? No? I have a quiz too. So in order, like, you guys can work on this, I have to take a look at what I put on the quiz. God, this is too hard. It's too much. We need next week as well, I think. So we have done binary to decimal, and we have done decimal to binary. What about decimal to hex? Five, 53, for example, in decimal, convert it to hex, and instead of dividing the number by 2, you divide this number by 16. So you are getting 3, because 3 times 16 is 48, and the remainder is 5. And do this again, and 35 is a hex number for 53 in the 10-based number system. What about hex to decimal? That's a hex number. A, what is A in hex? 10. So this represents 10 times 16 to the second. This is 11 times 16 the first. C is 12. And add them together, you're getting? I think. I don't know. Probably. Okay, so this is this, this is this, this is this. And finally, you are getting something like that. So that's 10-based number. So that's how you convert hex to decimal. What about anything else? Yeah, binary to hex, hex to binary. That's important. When you're programming the microcontroller, you're going to use it a lot. Binary to hex. So we group them in fours, the 4 digits every time. So for example, 1101, 0111, that's a binary number. Convert to hex, we look at 4 digits every time. Because hex number will carry out after 15. So 1111 equals to 15. So we do not need 5 digits for a hex number. So 4 digits for every hex digit. So this is the binary number. We just group them in fours. And this is 8 plus 4 plus 1, which is 13, is D. And this is 7. So D7 is the hex number over here. You just group them in fours. So what if you don't have multiples of 2? Like 1, 1, you have another 2 ones in the front. Like this. So what's the hex number up according to this number now? And you start from the right side, right? From the right-hand side. Fours, oops, 2. So I just make up 2 zeros in the front. It's not changing the number. So this will be 3. This will be D. This will be 7. All right. So what if this? The fractional number. What about that? What's the hex number of this guy? Do it one by one. So look at the left side of the point first. 4, oops, 0, 0, 0. And for the right side of the point, starting from the left, I only have 3 digits. So I need to make up one. It's not changing the number. So it's going to be, this is 0, 0, 0, 1 is 1. 1, 0, 1, 1 is 8 plus 3 is 11, which is B. Point 1, 1, 0, 0 is 12, which is C. Is that clear? Any questions? A lot of questions. You want to give up? Drop out? Burn down the campus? Hex to binary. Just do it reversely. Pretty simple. A, B, C. What's the binary number accordingly? What is A? So convert every digit into 4 bits of binary numbers. A is 10. So 10 is 8 plus 2, 1, 0, 1, 0. What is B? 11. 8 plus 3, 1, 0, 1, 1. What is C? 12. 8 plus 4. So that's the binary number of this hex number. That's it. Simple, right? A, B, C, point, D. What about that? 1, 0, 1, 0, just repeat it. Point. D is 13. 13 is 8 plus 5. Never mind, everything is recorded. Notes will be converted into PDF and uploaded to my website. And I'm always available for to answer any questions you have. You just need to ask. Anyway, you still have to work on the homework assignments, the quiz. Turn it in. next week? Probably not. We haven't covered. Maybe we can do it. I think you can do it. Yeah, let's go ahead and complete everything. We are learning something useful, right? In this first year lunch, worth your tuition. All right, we still have 10 minutes. Can handle that, 10 minutes. There? Are you okay? You're still awake? No? All right. If I'm telling you this is a octal number, and I'm asking you to convert this guy to a hex number, what can you do? I didn't learn that, right? You didn't learn this. But you know how to convert this guy into decimal, and you know how to convert decimal to a hex. So how to convert this number into decimal? This digit represent 1 times 8 to the first power plus 7 times 8 to the 0 power point or plus 2 times 8 to the minus 1 and blah blah blah. So that's the decimal number, and convert it to hex. That's how you work on this one. And after you get a hex number, you can convert it to a binary, which is covered this. Okay. I was not motivated when I was in college because I didn't know this kind of things are making money for me. I'm the person that I will not be motivated by anything except for money. Sorry for that. I know I can make money out of these technologies, doing all this programming and digital things. So I got motivated in my PhD doctorate. Too late, but anyway. So I just let you know. So learn it. Okay, it's useful. Addition, subtraction, or one one zero one plus 1111 in binary. How to do that? 1 plus 1 is 10, 10, 11, 11. Pretty simple. 1111 minus 1011. 1 minus 1 is 0. 1 minus 1 is 0. 1, 0. That's how you make it. What about you swap them? 1 0 1 1 minus 1 1 1 1. How this works? Probably not a good idea. What about this? 1 1 0 1 1 minus 1 1 1 1. 1 minus 1 is 0. 1 minus 1 is 0. 0 minus 1, I don't have enough number here, so borrow from here. So if you borrow from the previous digit, you are getting 2 here. So 2 minus 1 is 1. It got borrowed already, has nothing left. So it's a 0 left. So borrow, you got 2. 2 minus 1 is 1. It's recorded. Never mind. Watch it. Multiplication. 1 1 0 1 times 1 1 0. 0 times everything, 0 0 0 0. 1 times everything, 1 0 1 1, because 1 is 1 0 1 1. 1 times everything is this. 1 times everything, still 1 0 1 1. 0 1 1 1 0 1 0. So that works. Same concept when you're doing a decimal number multiplication. One more thing, pretty important as well. Boolean algebra. You guys are learning something need 3 weeks to cover in digital logic, which is number 1, not even one off. It's one, only one most important class you want to take. If you are going to a, computer engineering, computer science, or any digital circuit related, high technology related topics. It's the first step, okay? I'll just do this really quickly. So here's some rules being used in digital computers, okay? Because digital computer only has 1 or zeros, but not other numbers. So 1 and 0, so that's the logic, and that's the operator. You can write it down like this or this. They're the same thing. So 1 and 0 is a different operator. Doesn't like multiplication, division, subtraction. And is the operator in the computer system. So 1 and 0, the result is 0. 1 and 1, the result is 1. I will let you know why. That's the best way to remember this as a beginner. So really worth for tuition. Highly recommended. Okay. So this is the first operator, and the second operator is called logic or. That's an or logic. So 1 or 0, you can also write it down like this. This is not plus, okay? This is or. 1 or 0 is 1. So 1 or 0 is 1. That's the operator in the computer system. And why this is important? Every single operator has a digital circuit, integrated circuit is supporting that operation. It's fine. You don't need to. You don't know what's going on inside the computer now. It's built on the IC chip. That's how you design it. However, there's a way to remember it. Okay, think about that. 1 represents a. Do you know Michael Jordan? Michael Jordan, Kobe Bryant, LeBron James. So they are ones. They are the key player on the court can make you win. All right. 0, anyone else, like who cannot play basketball at all. Not just that, it's even worse. It's helping other team to win. All right. So if you are the coach, and means you have to let Michael Jordan and this guy to play for your team at the same time because it's unlogic. This and this, right? So you are going to lose. Is that making sense? 1 and 1, you got 2 Michael Jordans, or Michael Jordan and LeBron James. You'll win. Or you have an option. So you're not going to pick up this guy, right? So pick up this guy, win. What about 1-1? Two good options. Great, the best case, win. What about 0 and 0? No choice, lose. What about 0 or 0? 2 options, but both are pretty bad, lose. There's a little bit other things we're going to cover next week. So take this back, do whatever you can do.